Our fascination with the cosmos is ancient. We look up at the stars, filled with wonder about the vast distances that separate us from these celestial objects. For centuries, the limitations of travel have confined us to Earth, but our dreams have always soared beyond, fueled by stories of faster-than-light travel. Warp drive, a concept that has captivated the minds of science fiction enthusiasts, offers a tantalizing possibility. The ability to bend space-time and traverse light years in the blink of an eye. The idea of warp drive entered mainstream consciousness with the iconic Star Trek series. However, the theoretical framework for manipulating space-time finds its roots in Albert Einstein's general theory of relativity. Einstein's equations hinted at the possibility of distorting the fabric of space-time, creating shortcuts that could connect distant points in the universe. While Einstein's theories laid the groundwork, it was physicist Miguel Alcubierre who, in 1994, proposed a theoretical model for a warp drive that could actually work within the confines of known physics. Alcubierre's model, known as the Alcubierre drive, proposed the creation of a warp bubble that would contract space-time in front of a spacecraft and expand it behind, effectively allowing the craft to ride a wave through the cosmos. While Alcubierre's concept was groundbreaking, it remained firmly in the realm of theoretical physics. The amount of energy required to create such a warp bubble was deemed astronomically large, making it seem like an impossible feat. However, the seed of possibility had been planted, and a new generation of scientists and engineers took up the challenge, determined to bring warp drive from the realm of science fiction to reality. The allure of warp drive lies in its potential to shatter the limitations of conventional space travel. The vast distances between stars and galaxies present an insurmountable obstacle for traditional propulsion methods. Even at light speed, a journey to Proxima Centauri would take over 4 years. Warp drive offers a solution by manipulating space-time. It creates a localized distortion, allowing a spacecraft to surf on compressed space. This concept has captured the imaginations of scientists and engineers worldwide. Researchers are exploring various approaches to warp drive. One promising avenue involves manipulating negative energy density. According to Einstein's equations, it could theoretically warp space-time for faster-than-light travel. Recent advancements in quantum physics suggest it might be possible to create and harness this exotic form of energy. The journey from science fiction to scientific reality is often fraught with unforeseen obstacles and unexpected breakthroughs. The pursuit of warp drive is no different. While the challenges are immense, the potential rewards make this a journey worth undertaking. Achieving warp capability would necessitate an unprecedented collaboration between industries. A global effort, mirroring the scale and complexity of the Manhattan Project, would be required to pool resources, knowledge and manpower. Aerospace engineering, material science, energy production and quantum physics would need to advance in unison, each pushing the boundaries of what's possible. The aerospace industry, at the forefront of this endeavor, would face the challenge of designing and constructing spacecraft capable of withstanding the immense stresses of warp travel. New materials with exotic properties, potentially discovered through breakthroughs in materials science, would be needed to form the very fabric of these vessels. These materials would need to be lightweight yet incredibly strong, capable of withstanding the differential stresses of contracted and expanded space-time. Energy production would undergo a revolution. Harnessing the power of the cosmos, whether through advanced fusion reactors or yet undiscovered energy sources, is crucial for generating the immense energies required to warp space-time. The scale of energy production would need to surpass anything currently imaginable, potentially requiring planetary-scale energy grids. The quest for warp drive would redefine scientific exploration. Imagine research facilities unlike any we see today. Massive, sprawling complexes housing not just labs and workshops, but also experimental warp field generators and prototype warp-capable vessels. These facilities would be the breeding ground for innovation, where theoretical physics meets practical engineering. One can envision enormous vacuum chambers miles across, replicating the conditions of interstellar space. Within these chambers, experimental warp field generators would hum with unimaginable power, attempting to create minute distortions in space-time baby steps towards full-fledged warp bubbles. Superconducting magnets of colossal size would line the walls, their powerful fields used to contain and study the exotic particles and energies generated during these experiments. These laboratories would be more than just research facilities. They would be symbols of humanity's ambition, a testament to our relentless curiosity and our drive to explore the cosmos. The brightest minds from around the globe would converge in these hubs of innovation, collaborating and pushing the boundaries of human ingenuity in a collective effort to unlock the secrets of warp drive. Section 5. Dr. White's Vision-Bending Spacetime. Dr. Harold Sonny White, a NASA engineer, is pioneering warp drive research, focusing on the Alcubierre drive. His team at NASA's EagleWorks laboratories is exploring the use of a modified Michelson interferometer to study microscopic warp bubbles. This research could provide insights into space-time at extreme energy densities. Dr. Lentz proposes an alternative warp drive model, manipulating space-time geometry. Both Dr. White and Dr. Lentz represent the cutting edge of warp drive research. Their work is transforming warp drive from theory to engineering challenge. Section 6. Quantum leaps and artificial minds. The development of warp drive is intricately linked to advancements in two rapidly evolving fields: quantum computing and artificial intelligence. Quantum computers, with their ability to perform computations far beyond the capabilities of classical computers, hold the key to unraveling the complexities of space-time manipulation. Quantum simulations, running on powerful quantum computers, could allow scientists to model the behavior of space-time under extreme conditions, such as those within a warp bubble. These simulations could help optimize the shape and energy requirements of warp drives, providing invaluable data that would be impossible to obtain through traditional experimental methods. Meanwhile, artificial intelligence, with its ability to analyze vast data sets and identify patterns, could play a crucial role in managing the immense complexities of warp drive engineering. AI algorithms could optimize the design of warp-capable spacecraft, control the intricate interplay of magnetic fields and energy flows within warp drives, and even navigate through the distorted space-time within a warp bubble. Section 7. The Ethics of Warp, a Universe of Responsibility. The potential of warp drive extends far beyond mere technological advancement. It raises profound ethical and philosophical questions about our place in the cosmos. The ability to traverse vast interstellar distances at unprecedented speeds would bring with it a responsibility that extends beyond our planet and encompasses the universe. First and foremost is the question of contact with extraterrestrial life. Warp drive would make encountering other intelligent civilizations a real possibility. We would need to consider the ethical implications of such contact, how to approach other intelligent beings, how to communicate, and how to avoid potential conflicts. The potential for colonization also presents ethical dilemmas. Warp drive would make it possible to reach and potentially colonize distant planets. However, we must grapple with the ethical implications of claiming ownership of other worlds and the potential impact on any indigenous life forms that might exist on these planets. The development of warp drive would necessitate a new era of international cooperation and a shared sense of responsibility for the ramifications of this technology. It is a responsibility that would require us to act not just as citizens of Earth, but as citizens of the cosmos, mindful of the potential consequences of our actions on a galactic scale. Section 8. When stars become neighbors, potential impacts of warp travel. The successful development of warp drive would have profound implications, reshaping our understanding of the cosmos and our place within it. Travel time to distant stars and galaxies, currently measured in lifetimes, would be reduced to a manageable scale, opening up a universe of possibilities. Scientific exploration would undergo a revolution. We could send probes and eventually human explorers to distant star systems, studying exoplanets, investigating black holes, and unraveling the mysteries of the universe firsthand. The wealth of knowledge gained from such expeditions would be immeasurable. advancing our understanding of physics, astronomy, and our own origins. The potential for resource acquisition is another factor. Warp drive could enable us to reach asteroid belts and planets rich in valuable resources, potentially alleviating resource scarcity on Earth and fueling further technological advancements. However, alongside these benefits come potential challenges. The ease of interstellar travel could exacerbate existing conflicts, leading to competition for resources and territory on a galactic scale. We would need to establish new paradigms of governance and cooperation to ensure that warp drive benefits all of humanity and does not lead to interstellar conflict. Section 9. Conclusion: A future among the stars. The pursuit of warp drive is a testament to humanity's unyielding curiosity, our relentless drive to explore the unknown, and our yearning to reach for the stars. While the challenges are immense, requiring groundbreaking advancements in physics, engineering, and international cooperation, the potential rewards are too great to ignore. Warp drive is not merely a technological goal, it is a symbol of our ambition, our desire to transcend limitations and explore the universe that beckons us from beyond the horizon. It is a journey that will challenge our assumptions, redefine our place in the cosmos, and potentially lead us to new worlds and new understandings. While the timeline for achieving warp capability remains uncertain, one thing is clear: the journey itself will be as transformative as the destination. Along the way, we will unlock new secrets of the universe, push the boundaries of human ingenuity, and perhaps, in the process, discover a future among the stars.